Okay, welcome back. We're going to be, I think, adding some more features to our taxi class. There's our taxi right now. All it does is has no hitbox other than grounded platforms, and it just spawns and walks to the right. So we need to do a couple things with his behavior. We need to make him track a jockey instantiation, and then we also have to determine where he spawns so that we can get a starting point for how to code his AI, and then we can watch the original and how the original handles it to see if we can pick up on any patterns with its AI. So let's take a look at the original here. And what we're going to be testing for is we're going to catch an egg. No, we're going to pop a vulture, kill a vulture, pop an egg. Oh my god, get popped. We're going to let the egg hatch into a jockey and then watch. Oh my god. Then we're going to watch what the taxi does. Okay, there's our egg. So let's watch for our taxi when this hatches. Come on, hatch. 3, 2, 1, hatch. There it hatched. Okay, it comes in from the same Y and it came in flying. Oh, and there's a pterodactyl. And then it upgraded to a hunter, which is white. And it looks a little, the white tier system, they flap a lot more erratically. They move a bit faster on DX. Oh, there it goes. So it has vulture to vulture collision, but it had no, it didn't die. It just, it switched DX and then, oh my god. Yeah, they're harder. It switched DX. It bounced off a vulture. So it needs object detection, but it doesn't do anything if it detects us as an object. It detects it if it detects any in our global vultures table, whether or not it's okay. I also noticed when my dad was playing it at Thanksgiving that he was able to pick up a jockey and it gave him the bonus yellow score, which should only happen if the egg hadn't bounced off the floor. I don't think I've ever seen that diagonal bounce. Oh, there's a pterodactyl. So we have to debug our double score as well sometime. Let me just make a note of that so I don't forget. We'll say debug double score with jockey collection, I'll just say. Oops. Now, we need to add ground platform collision before we forget, because right now it's just platform collidables, which means it'll fall through the ground at this point. It's just not getting the chance because we spawn it too high. If we spawn it lower, let's say 200, maybe more than that. Let's do like, what is our height? Our height is 240. So we want like maybe 190, right above the ground. I'm trying to prove that it'll just fall through the ground. Let's try that. Y190 is where we instantiate our taxi. And we'll need it a little bit higher. It can be 180. No. 150. And then not so far to the right. And it falls right through. So yeah, we need to add we need to add ground platform collision. and make us stop getting gravity applied to us if we're platform, or actually if checkGrounded is true. That's why we wrote that function. Yeah, because actually checkGrounded was checking through even our ground. So I wonder if we do that. I wonder if we just, instead of doing platform collision in our update in our taxi class, instead of doing collidable platform collision, maybe we do if checkGrounded is true, don't. I guess it comes down to how detailed is our checkGrounded function and where is it written? Play state? No? What the fuck? Yeah, we should have programs, or we should have functions in our, before our update function here, we should have our custom functions, but we don't have any for the play state. That means the checkGrounded function is probably in the ostrich class, with which it is. So now I can only run checkGrounded on an item of an ostrich type. So I can't use it because it's local to this. So I guess, I mean, this is, let's take a look at what it does. It's checking our ostrich's Y, seeing if it's equal to the given platform's top left quadrant in its Y position, current Y minus self height. So the top, it's the top of that platform. We're saying if Rx is to the left side of the rightmost side of our platform with a buffer, Jesus Christ. Yeah, if we're to the left of that and our right side is bigger than the leftmost side of that platforms plus the buffer amount, then we're returning true. So why do we have to check? Oh, okay. So checkGrounded runs in conjunction with appropriate bottom collide logic implemented. So it's like once our bottom collide returns true, then we set us to be at the level of the ground of which it just collided. But in our case, we need to just add it as a collidable to our ground platform. So they're not decoupled, which means we'd have to just like copy and paste the same exact logic if we wanted to put that into our taxi class, but we don't want to do that. We just want to see, we're going to pass it in the ground platform and write code to see if it is sank below that. And if it has, we're gonna not only set it to grounded, we're gonna set the vulture to grounded, but we're also going to move its Y position, and also there's another Boolean that we need to flip that affects either how it spawns or, hold on. Yeah, I don't know. Let's just work. I mean, let's just do something. We need to check if it's smaller than the ground platform, which should be a global, and that's in our play state. So here's the ground platform object that we're giving it a platform object which has an x, a y, a width, and a height. So we can write a function that uses any of those fields and have it work. So we're going to say if we have bottom collides already, that takes in a collidable, of it just needs x, y, width, and height. So let's run this function on it. So it's colon, bottom collides, object, colon, bottom collides, and then a function is in parentheses like this. And this is going to be the parameter we pass in, which is not going to be any collidable cycling through the platform of collidables, but it's going to be ourself, our ground platform object. That's the going to become the argument to the bottom collides function that we're running. See, look, we not ground platform running the function on, but ourself. If our taxi object bottom collides with the ground platform, then we need to do those things. We need to set our y position. So our self.y gets assigned whatever the ground platform's y is, which would be the top most quadrant. That's a bad way of saying it. It's like if there's an origin point, it's at its top left. So y is how high the top leftmost point of our ground platform is. And also that would be, our x would be the other number to keep track of. Like, well, hold on. Because we're setting its y to be not only that, but minus its height. So we're putting ourselves a taxi height above the top of the ground platform, and then we need to trigger our Boolean. Our music stopped. So we need to say we are no longer, see, and the thing is, we, in our ostrich class, we have a isGrounded. And we're using our checkGrounded function, which is local to our ostrich class, which is screwing us for our taxi. So I think there's a better way of doing that in the future so that we can use the checkGrounded function on things more than just an ostrich, but on any object that has an x, a y, a width, and a height. So now we either need to write that function into this locally, which is also a wrong way to, it's the wrong way to do it that I'm just thinking of now. So I feel like we should just kind of fix it. So that entails finding, how do I put this? What should I do? We need to be able to use our checkGrounded function on things more than just our ostrich. So we need to put it in our play state. We need to define it in our play state. And then we need to find any instance where I use that checkGrounded function, and instead of saying running it, actually it should work that way. Wait, sorry, it's so hard to explain this. I guess let's just try to do it because I don't know how to do it. I'm just like theorizing, trying to figure it out. We should just have a Boolean that says isGrounded, and then we'll write another. No. It's I'm conceding. If I say we're just going to write another checkGrounded function, I'm conceding that I'm just going to do it wrong, and then I'm going to do it wrong again. Then if I have another class where I need to detect, isGrounded, I'm going to be wishing I had that global function where I can use it on anything. So part of me feels like we should just fix it. Let's just fucking fix it. Let's try it. So in our other function, our checkGrounded is based off where we set it, which is right here. So then we can say here, like, bottom collides, then no. We set its Y appropriately. Then we need to stop applying gravity. And then we need to constantly check whether or not we need to reapply gravity, because otherwise it can't walk off the platform. So that's what's so complex here. So do we say we just need to have similar... Gosh, I don't like writing the same mistake again. Like, I would rather have figured this out a better way. But we're going to say if self y is equal to exactly this, meaning it was just set to that, and it needs to be before we apply gravity. If Ry is set to where it sets after it collides, then check grounded. See, okay, so this is where we're going to film it, or fix it. Because then we need a check grounded function that we can use in our play state, referencing two objects. So we need to write check grounded as a function that takes two arguments. One is the self, and then the other object is a collidable platform that it can be standing on, which right now is all of our platforms, but also the variable ground platform. They're in different tables because the ground platform has to shrink over the waves. So I'm still trying to write it in such a way where I'm not modifying any details of those other platforms. I'm only messing with the ground level. Which I still need to do yet. Jeez. So we're going to say that our check grounded function, we're going to say we're not going to say any logic. We're just going to specify run the check grounded function on self. And as arguments, we're going to give it two things. We're going to give it ourself. We're going to say, hey, compare me to this. It needs to be a collidable platform or a ground. So this functions in how we have to, I shouldn't say function because it's actually a computer term. So to be clear, I would say, like, we need to make sure that our ground, when it eventually shrinks, can still use this logic for whether it's grounded or not since the ground is shrinking. So ideally we would want this function to not only be local, instead of being local to the ostrich and then writing a local one to our taxi, we're using it in our play state. We're saying here's two objects. Is the first one on top of the second one? That's what it's really saying. Because when you get into the logic of what our checkGrounded function in our play state is going to be, it's going to be exactly that. Like that's what coding is. You have to think it and then apply it in the way that it's intended, not in the way that it is correct, not the way you initially try to do it. It's in a way like it's so complicated. There's no one way to do it. You just have to like get it to work and then learn, and then you might pick up some new tricks and stuff. But let's try to do it. Let's try to do it. Because we're saying running the checkGrounded function on ourself, passing it ourself, and we're also passing it any collidable platform. So we either need to cycle through this and say we'll need to cycle through this. We need to cycle through our list of collidable platforms, but also on our ground platform. So we can run it once on our ground platform, and then we run it a collidable platform's amount of times, because the pairs function will iterate through every object in a table at its key and its value. And in this case, our value is platform objects. So we would say for key platform in pairs collidable platforms, just like below, cycle through all our collidable platforms. Then don't forget the indentations, or like the ends. We're gonna say we're gonna run that function in relation to itself, which is just a taxi object, and we can have potentially every filter that's on screen can become a taxi object on the screen at the same time. So we have to reference things we just have to declare it that we what am I trying to say here? Run it on every single vulture, or every single ground object. Collidable, god damn, it's so ground collidable objects, or collidable platforms. So, okay, platform in pairs, collidable platforms. I need to stop talking so much and just try to write the freaking code. We're gonna run. Talking helps me through it. It's just so hard to think. We're gonna run the checkGrounded, which we haven't written yet, but the checkGrounded function will take two arguments. We pass in itself. We pass in platform, which we're spelling exactly the same as the value of this pairs function. What that'll do is cycle through every object, which in this case is objects referred to as platforms, which are in the table. It is a platform class instantiation. I sound like a crazy person saying this. And this is like it's not simple, and clearly it's not simple. But this is like, I'm not making Uncharted here. Speaking of Uncharted, I need to pick up my ring. Okay. We're making progress. It's so hard to wrap my head around this. But yeah, we're running through. We're not only running our checkGrounded function on the ground platform, which can shrink it depending on the wave, but we're going to say, are we also checkGrounded on any platform in the table of collidable platforms? Then we have to say, now we put in some logic and we say if it is checkGrounded, which we still have to write that function. Right now it wouldn't do anything, but this is just like how it might work. So if that Boolean evaluates to true, then we need to not apply gravity or negate our gravity. But since we're doing this, checkGrounded works. God, it's so complex. Because checkGrounded works by detecting the Y position, and if we're standing on the platform or not. We're exactly standing on it, and we only get that if we happen to fall exactly where our Y's perfectly match up, but I don't floor our values, so that probably wouldn't happen. And then 2, if we bottom collide with the ground platform, we set our Y to the top of it. That's the instant we are equal to that. So that's the only frame a checkGrounded would return true, is the next frame, delta time after we run that function, and it comes back true. The bottom collides right here. So we need to say no, I think we need to set our Y. How does this work? Because we need to set our Y after we apply gravity so we don't accidentally move us. This is so complicated. Gosh, it's hard. It's hard to... If our checkGrounded is true, then we would say, hey, don't apply gravity. So maybe when we do apply gravity, we say, hey, first of all, just check if you're grounded. If not, cool. Apply gravity. But if we're grounded... Okay, so here's where the magic happens. Because we would say, hey, we are grounded? Okay, don't apply gravity. So we can say, oh, and here's the thing with Booleans, because it's like we don't actually want to technically do anything, we want to not do something. So we can say, if we're not grounded, that's when we apply the gravity here. And all our gravity is a Y velocity representing as delta Y. So we're saying our delta Y gets assigned our current Y velocity plus gravity scaled by delta time. Fucking Christ. Excuse me. So yeah, that'll move us downwards. And then if we are checkGrounded, we're going to say do nothing. That's what it's actively doing here, by the not. Only apply gravity if we're not checkGrounded. And then we have to comment this one out. So that one doesn't update. It only updates it if we're not self-grounded. We also need to do it on this one. So we need to say if not checkGrounded on this one, or not checkGrounded on this one. Inclusive or in the way. I mean, like, how do I explain that? Yeah. Either of those are true. And it's not, what do we call it? Ground? Oh yeah, that is it. Ground platform. So I think that's right. We only apply gravity if we're not checkGrounded on any of those things. And then let's take... Do we have... Hold on. Gosh, this is so confusing. I'm so happy in life right now. It's having a hard time focusing. I've been really happy. It's hard for me to wrap my head around what the fuck I'm doing. I'm applying gravity only if this is not check-grounded and this is not check-grounded, but right now that isn't a function. We used to have it local to our objects, but we want to run it not only on a taxi object and not only on an ostrich object, but we want to run it on 2 collidable objects. That's why we give it 2 arguments, one of which is the one whose y is on top of the second. That's what it means, basically. Gosh, okay. I need to stop talking and just try to code it, but talking... I'm just going in loops, man. I just need to be okay with over-explaining because I'm not trying to like mansplain it, I'm trying to figure it out myself. Let's see what this does. We should be only applying gravity if our y is not exactly on top of another object. But we don't have, we didn't write that function. We didn't write that function yet. We have the local ones to our objects, but we need to write this function in our play state. Then in our play state, no. Yeah, if our play state has it, see, I don't know if I'm allowed to do that, if I'm allowed to run function from over there, but we have to figure this out. So right now we don't have any functions before our update function, so we can give ourselves a new one. We run it on the play state, and we say it's called checkGrounded, and it takes in 2 arguments, and the parameters of which are top object and bottom object. Bottom object. Okay. We can't forget our end. So now we need to say, this is where we need to ask whatever we're doing here. All of this. We need to say, our checkGrounded function checks if not self.y, but if the parameter top object.y is equal to the bottom object's y. See, this is the way to write it. Instead of self and having it for objects, for ostrich objects and vulture objects and taxi objects, now we can just use it globally, but I have never done that before. Hence the not having functions up here yet. It's just I'm trying to learn how to big brain this stuff, you know? I mean, all the programming is just like Legos. It's just like Legos. It's just pieces that you figure out how to use in cooler ways. Sounded awfully confident for someone who hasn't written it yet. Okay. So only if our y had just been reset via bottom collides in our taxi class. Jesus Christ. As long as that, we're going to cycle through the platforms. And if we're not grounded, meaning there's not see, this is the function we're running. So we just need to say when we actually execute our checkGrounded function call, we need to pass in not only a list of all collidable platforms, but we need the ground platform as well. Only apply gravity if those are false. But they're decoupled though, so we can't run this. we have to say, gosh, what is going on? What would we do? A checkGrounded function needs to return true if it's we don't do the logic here. We would do the logic in the update for in the main update function. But for now, I'm just going to put it here so I can better do this, because this function should return true or false. So if the top object is equal to if the argument's passed in top object, bottom object, if the top's y is equal to where it would be standing on the bottom object, return true because we're grounded. Then we'll say otherwise all the other time return false. So now we need to run this check grounded. Oh, but then this is where I'm getting bumbled, where it's flustered. What do I call it? I believe you can only run a function according to how it's defined, which is on a playstate object, of which we only have one, so we can't. I've already tried where I try to call a playstate member from another function locally and print it to screen, and it doesn't work. So I guess let's just test that assumption and say, first of all, for right now, this can go commented out so I can see where this code would actually go. In this code, we're going to see if we can run it on a subdomain, I don't know what you would call it, an object outside of the playstate. And playstate is of class states of our state machine, of which we didn't write the code for. We're using just the library for. So exactly in terms of how the playstate functions that I've been using work, I only understand it so much because this playstate is limited by whoever included the base state class that we're using, because we didn't write that code. That code allows us to switch and say, hey, if it's playstate, run the play function. If it's the title screen state, run the title screen, and then, game over state, trigger game over, ask for a new one. It's just a way of kind of switching different groups of code, navigating through your main, because your main is handling all the state machine updates. God damn, okay. So yeah, we just have to trust that the code that changes the state machines can be worked with in such ways where I'm trying to do what I'm doing globally. One thing I hear about Lua is that everything's global unless otherwise specified as local, but I've seen that's not the case. Even in a for loop, if you initialize I, that's local to that scope of code. So you use I again and it's already wiped. It's a new allocated. I don't know exactly how it works. So I can't say whether or not we can run. We're trying to run that function on our taxi. So we're going to say, how do you say this? You say playstate, since our function is in playstate and we're running the checkGrounded function, giving it two arguments, one of which is our taxi, the other which is the ground platform. It's actually really just any platform of collidable platforms. So when I when I do the code, oopsie, when I do the code there, if we call them collidable platforms, we would say, play state runs the function checkGrounded. God dang it. Yeah, no, that's right. Because we're trying to access the checkGrounded function from our play state in our taxi. I don't think that's possible. I don't know how to make it global other than trying to do that though. So if play state checkGrounded on self and platform, and remember platform is the values of which are being iterated through in this pairs function when you pass it in a table. But yeah, we're not actually this table, or this is a table of tables basically, because everything in Lua is a table. So all the objects in our collidable platforms table will get cycled through. We have access to it in that variable that we set as the value. So we're saying if it's not checkGrounded on the platform of collidable platforms, or it's not self-grounded, we need to try to run that from our play state. The function checkGrounded run from our play state, giving in our self, which is our taxi, and then also a ground platform, which is separate from our collidable platforms. If they're not grounded on either of those, that's when we apply gravity. So if we are checkGrounded, we shouldn't fall. I doubt it's even gonna boot though. Taxi 55. Yeah, right there. That would make sense. $66. Oh, we started typing something there. So yeah, every frame we're checking whether or not we have bottom collided with a ground platform or a collidable platforms, and we're checking the height, or we're resetting the height so that we can use this checkGrounded, which uses the accurate height to apply gravity. Only if we're not have just been reset. So it should make us stand. God damn. See, look, it says bad argument to 1 on playstate 62, which is, oh, actually, this is a different. Bad argument to pairs table expected. This isn't in pairs though. Where's the pairs that it's referencing at 63? Oh, 62. I'm not exactly sure. I don't know how to run that function globally on everything given 2 arguments. I don't know why it's failing it. Well, let's keep reading. Tables expected to 1. That's weird because 62 doesn't have any. Platforms got nil. Table expected got nil. Argument 1 to pairs. Argument 1 to pairs is right here. It's not on line 62 though. And why wouldn't our collidable platforms, why, those aren't nil, those are a table of collidable platforms, because that's how this works. At this point, it's like I can't even remember where I wrote the code for the collidable platforms. This is a mess, man. This is a mess. I don't know why it's failing at the line it is. But let's see if we turn off. It actually wasn't saved, so let me save it. Dude, it freaking landed on the ground platform. That's what we're trying to get it to do. It wasn't doing that before. It was falling right through. So success. We were able to run a function from our play state, which we had not had functions there before. We're running it on an object within our play state. And we're doing that right here by saying play state, run that function, and the function is using our self, which is our current taxi, and a platform, any given collidable platform, and our ground platform. And we're only applying gravity if we're not check grounded. So our check grounded has like a little bit of a bug because we apply gravity every frame. We need to only turn back gravity upon which check grounded would be false now, meaning there's no platform underneath them all of a sudden. But we need to not apply gravity every frame once we're check grounded, so we don't fall through the platform, or like we just need to not. I'm saying I don't want to update our Y position every frame. I just want to say, okay, now that our Y is no longer falling, we're grounded. So we say check grounded gets true. And then if we're check grounded, we don't apply gravity. So instead of saying when to apply gravity, we can also say when to not apply gravity. And we can, or actually, yeah, if we do it first, we can exclude every time we want to ask to reset our gravity. Gosh, it's so hard. I don't know how to explain this. I just like, I'll be on a train and then I just fall off it because my mind is too stretched thin. We just need to say, it's like we're trying to not fall, so we need to say, hey, taxi, you're no longer, or you're actually grounded now. I mean, yeah, like you are on the ground. You're not in trouble, Vulture or taxi. We're saying our grounded field gets set to true, but we don't have a grounded field yet. So let's give ourselves one. Now we got one. We need to initialize it. I guess we initialize it to false. I don't know. I don't actually know if you have to initialize as a, because it's Lua is a weakly typed programming language, so you don't have the it's like this could be a boolean if I tell it false, then it knows it's a boolean. But if I just say, hey, we have a field called self-grounded, does it know how to say? I don't think it would. I don't think it would know. The compiler couldn't, or the interpreter couldn't read between the spaces correctly. So I think you have to say, you have to initialize it as something. So we're going to initialize it as false so we can apply gravity. But we only want to apply gravity if we're not grounded. Yeah, that's when we want to apply gravity. So we're going to say, that's what we're doing. Yeah, we're only doing it this. So this is where, is this where we set it equal to true? And then now that it's true, we can ask before that, we can say, if we're grounded, you're gonna not apply gravity. So we're gonna say, if we're grounded, do one thing, otherwise apply gravity. So the if not should be else. So we don't want to apply gravity if we're grounded, but that means we need to check grounded and set grounded back to being false so that we can apply gravity again. That's what that means. So if we put it here in our else, we can say, okay, so you're not grounded, then, see, why would we run check grounded there? This is so hard for me to wrap my head around. How do we only apply it if we're grounded? Don't apply gravity. Otherwise, you know what? I think that can work. Putting it in our else. So we're only applying gravity if we're not grounded. But as of this point, we're never becoming grounded true. Excuse me. That won't work. Oh my God. That won't work. Because then we're never checking grounded. We're never setting it to true. I'm not going to be able to figure this out tonight. I tried my best trying to program. We'll leave it at that. Let's hope we can just run it. You know what? It's almost like I shouldn't even commit this one. Because I fucked up so hard. But also, I actually succeeded a little bit. If we just undo to the point where it was running and we hadn't screwed it up with trying to add self-grounded, we can just save it there and then see if it runs. So it runs. I don't know why it falls off there, but it doesn't quite run the whole way. But the thing is, when we watched the original, when it spawned walking and then it jumped right away and then it never really went back to walking again. So it's almost like, yeah, I don't know. We have to just assess what exactly we need it to do and tell it exactly how to do it. It sounds so simple. It's just like, all you do is type in the right shit, man. Then it works. Anyways. We're making progress because we're walking on the ground platform and we're walking on the, at least I'm assuming we're walking on the collidable platforms as well. If we spawn our taxi higher again, get 40, maybe it'll walk. Yeah, so it'll walk on collidable platforms, it'll fall, and it'll walk on the ground platform. Okay. I mean, that's something. I mean, we got at least one thing. I'm gonna take a look at our get diff because I'm curious. So we only apply gravity if we're not grounded, check grounded. You know what? That's pretty impressive because I didn't know you could write a function in a play state and use it locally, because I've tried to access fields in our play state locally in an object, and that has never worked. So I'm surprised that worked. So we're running bottom collides. If we bottom collide, wow. I don't know. Oh, okay, yeah, this is commented out. I was gonna say, I don't know why we have that here. I guess we have to decide if we take that out completely. I think we do. Because this is now moved. We now apply gravity here. We only had that saved in case that it didn't work when we ran that function here, where we asked the same question and applied gravity. But it did work, so now we can commit without that mess still in there, which threw me off when I was glancing at it because I didn't see the end of the comment so easy. But come on, man, let me quit. Let me quit and say git add everything, commit with a message saying we added global function checkGrounded, added global function checkGrounded, and taxi. I want to say taxi checkGrounded. No, because that's actually wrong code. So I want to say what we did short form, but I guess I can just say checkGrounded on collidable platforms and ground platform. Camel case. And then git push. What do you mean? Cool. Jesus Christ. Okay, we're done. Sorry that was so... I talked the whole time, but like, it's just helping me get through it because I don't know what the hell I'm doing over here. It seems to be working one little step at a time though. I'll catch you guys tomorrow and we'll get some more functionality added in.